Alright guys, so in this video I wanted to talk about the reticular layer. The reticular layer is the lower of the two layers in your dermis. Okay, so let's get started. The reticular layer has several things, including fibroblasts. So just like the papillary layer, it also has fibroblasts. Except these fibroblasts are going to produce it's going to produce the things required for thicker elastic fibers and thicker collagen fibers. And that means that this particular layer is going to be a lot more dense and a lot stronger or a lot thicker than this papillary layer. Now, the reticular layer is also going to be a lot less cellular, so it's going to have a lot less cells. It's going to be made of a lot more just proteins and not cells. The reticular layer also has two kinds of corpuscles. So while the papillary layer has Meissner's corpuscles, the reticular layer has Pacinian corpuscles so they look like this. As well as Ruffini's corpuscles. These are not great drawings, by the way, so if you would like a more accurate drawing of these corpuscles or anything else, there are probably some better pictures if you look them up, but I'll do my best. Okay, so these are Ruffini's corpuscles. So Pacinian corpuscles are going to be able to detect pressure change as well as any vibrations your skin might feel on the surface. So if there's any vibrations on the surface, your Pacinian corpuscles will feel that. If there are any pressure changes on your skin, your Pacinian corpuscles will send signals to your brain and you will feel that. Ruffini's corpuscles, on the other hand, will detect torsion and stretch. So if your skin is stretched somehow or rotated somehow in some way, these Ruffini's corpuscles are going to detect that. It's worth mentioning that you also have Krauss's end bulbs in your dermis, which are going to detect cold. You are also going to have sweat glands in your reticular layer. Two types of sweat glands. So first of which, and the ones that are in everywhere in your body, called your eccrine sweat glands. And these eccrine sweat glands are going to look a bit like this. I'll do my best to draw a simple sort of version of it. Actually, if you want an accurate representation, just probably just look one up, but yeah, I'll just draw a spiral to represent part of the eccrine sweat glands. But it's going to be made up of two parts. First of which is the secretory segment. So secretory segment, and it is going to produce parts of your sweat, and then you also have your duct segment. So that's this part up here, so your duct segment. And that is going to carry what your secretory segment produces up to your skin through pores. So there will be pores. Let's draw some skin. This is like a little segment of skin, I guess. Right? And there are going to be these little pores and sweat will be able to go onto your skin via those pores. Just erase that. Okay. Okay. What are these eccrine sweat glands actually going to produce? Well, they're going to produce water, low amounts of protein, so low amounts. Well, it's going to produce protein, but when the sweat that reaches the top of your, when the sweat that reaches your skin is going to have low protein, so low amounts of protein. Sodium chloride, urea, uric acid, and ammonia. It's going to secrete this. Okay. When this mixture sort of gets into the duct segment of whatever amount of concentrations goes through the duct segment, some sodium and chloride ions are going to be reabsorbed, and that way you're going to lose less electrolytes when you sweat. So one of the main functions of sweating is thermoregulation. So you're going to lose heat via sweating, and you don't want to lose that many electrolytes when you're sweating. So you're going to reabsorb these sodium and chloride ions. Okay. You also have things called apocrine sweat glands. And I'll actually just draw a hair structure. I won't redraw. I'm going to talk about hair in a second, but right now we're just going to focus on the apocrine sweat glands. But there are going to be apocrine sweat glands attached to these hairs. By the way, this hair is much bigger in real life relative to these dermal papillae and epidermal ridges. I'm just drawing it small because I don't have much space. But there are going to be apocrine sweat glands, and they're going to lead off into the hair area. And the things that they secrete are proteins, carbohydrates, ammonia, lipids, other organic compounds, and pheromones. So they're going to release pheromones. And they only actually become activated during puberty. So before puberty, these are not going to actually work, but after puberty, they will. Okay, so how is sweat really regulated? Well, the eccrine sweat glands are going to respond to acetylcholine. That A doesn't look like an A. Okay, acetylcholine. Okay, acetylcholine these eccrine sweat glands are going to respond to acetylcholine, and they're going to sweat. You're going to sweat more from your eccrine sweat glands when acetylcholine is released. Eccrine sweat glands mainly respond to heat. Apocrine sweat glands, and I'll actually write it out, apocrine. I'll draw this little circle here to represent an apocrine sweat gland. Apocrine sweat glands are going to respond to norepinephrine. Norepinephrine is released when these stimuli are present. Stress, fear, pain, or sexual stimulation. These eccrine sweat glands will respond to heat. In other words, the hormone, or in other words, acetylcholine, and apocrine sweat glands will respond to norepinephrine. In other words, that means that it responds to stress, fear, pain, or sexual stimulation. Or it responds directly to norepinephrine. Eccrine sweat glands respond directly to acetylcholine. The response of the glands to external stimuli are all regulated through the central nervous system. Now let's talk about the hair follicles themselves. Alright, so I've pretty much drawn this hair, and I want to talk about where this hair actually is. So wherever there is a hair, so in this case there's a hair here, this sort of barrier is actually going to come down. So there's a basal lamina right around like that that fills this area. It will actually come down and sort of encoat this hair and come down with it, so that this hair technically is separated from the dermis. So there's sort of like a little layer around it that comes off from this barrier. So I'll draw a simpler version. If there was a hair right here, then it would come down, back up, and then the barrier would continue. So with that out of the way, let's talk about this right here. This is actually going to be called the dermal papilla. So you might see a connection between this and dermal papilla. And obviously there's a connection between this over here and these dermal papillae, right? Okay, let's erase that label. Okay, let's start from the bottom now. This bottom bit is going to contain hair matrix cells. These hair matrix cells are going to differentiate into two things. Or they're going to divide and become two different things. First, they're going to divide into keratin producing cells. I'll talk about those in a second. The other thing they're going to produce, or they're going to divide into, is the internal root sheath. This internal root sheath is going to surround the hair. And again, I'll talk about that more in a bit. Since we're talking about the internal root sheath, as we'll mention that the outside of this hair follicle, not the basal lamina which sort of encoats it, but this part, like the actual outside, is called the external root sheath. So the internal root sheath is sort of this inside bit, the external root sheath is that outside bit. Okay, Anyways, back to these keratin-producing cells. By the way, note that I have not actually drawn an apocrine sweat gland just for simplicity, but there might be an apocrine sweat gland on this hair. Okay, but anyways, these keratin-producing cells, they're going to actually move up as once they're born, or once they're there, they're going to move up because these hair matrix cells keep dividing and creating more of these keratin-producing cells. The older ones are going to move up through the hair, if you will. So as they move up, they're going to come across this structure. And this is actually a muscle. It's called your erector pili. It's called an erector pili. It's with all of these hairs. And when they tense, it's actually going to make that hair stand up straight. Okay? So the hair will stand up straight. So that's how your hairs stand up straight. Okay, anyways, these keratin-producing cells continue to move up. And by the way, as they move up, they're actually being keratinized. So keratinization is occurring so that once it actually reaches this area over here, they're completely keratinized. And if you've watched the past videos on the epidermis, then you know what that means. If not, go back to that video. But it will be keratinized at the end here. Okay. So these are going to move up and they're going to be keratinized as they go up. Okay. There's going to be something called a follicular bulge over here. It's going to contain stem cells. And these stem cells are actually going to do two things. So they're going to contribute to the growth of the hair. So all of these living cells, like it could be the matrix, the internal root sheath, and some parts in the living part of the hair. So that's the follicular bulge, and it contributes to two things. First, it is going to contribute to just the hair cells, and it's also going to contribute to the repair of the epidermis if you lose any epidermal cells, any part of your epidermis. Okay. As these keratin-producing cells move up and go further on through keratinization, eventually they're going to reach this sebaceous gland. Sebaceous gland. Okay, and this sebaceous gland contains cells called sebocytes. It's going to contain sebocytes. And these sebocytes are going to produce sebum. Okay, and this sebum, so it's going to produce sebum. And this sebum is going to coat this hair. It's also worth noting that this is where your internal root sheath terminates. So your internal root sheath will be no more once it's past this sebaceous gland. The reason for that is, so this internal root sheath is going to disintegrate once it reaches the sort of entrance to this sebaceous gland. But anyways, the sebum is going to make sure that is going to help make sure that your skin doesn't become too dry as it comes up, coating the hair and reaches the skin. It's also important to note that there are melanocytes with these hair matrix cells, and they're going to add color to the hair matrix cells, the same way they do in the epidermis, in a similar way they do in the epidermis. That pretty much concludes this video. Thank you.